Okay, so for this one, first step, of course, we're going to start on one side of the equation. We'll start on the left side to deal with the parentheses. 4 times 3x is 12x. 4 times negative 7, negative 28. Now this is negative 2 times 5x. Negative 10x, and negative 2 times 1, minus 2, negative 2. And then we got plus 5x. So now we will combine 12x, negative 10x, and 5x. 7x. So negative 28, negative 2 is negative 30. On the other side, parentheses, 3 times 2x is 6x. 3 times negative 2, negative 6. 3 times x is positive 3x. 3 times negative 3, negative 9, and then negative 5x. So now we've got 6x, 3x, and negative 5x makes 4x. I don't know why I got pink. 4x. And then negative 6 and negative 9 is negative 15. Now I'm going to get rid of one of the x's. We're going to get rid of the 4x since it's the smaller one. So 3x minus 30 equals 15. And from there we will add 30. 3x equals 15. Should be a negative there. And finally, divide by 3. X equals 5. What do you think? Not something you want to do every day.
Still not matrix, so I'm okay.
Still not matrix? You want to get to matrix?
Kind of just to get them over with, but at the same time, it's like I really don't ever want to see those again.
That's kind of on our list of optional stuff. If we have time in the semester. You guys are kind of slightly ahead of pace, though, so there's a chance we'll get to them.
Be good, because I'm sure we'll use them.
Are we gonna know proofs?
No proofs.
Thank you.
They hadn't invented them yet when you were in high school. I'm just kidding.
Well, probably didn't.
Let's have you,
Inventing.
in your notes, see if you can try this one.
They want you to,
Yeah, good question. Are the parentheses, what's the purpose of the parentheses? That's really a negative 1, is what that's saying. There's a negative 1 times all that.
yeah, it's basically just reverse distribute the negative sign.
Yeah. So what you're doing, yeah, everything inside there is multiplied by negative 1. So the 2x doesn't change. This would be a negative 5x and a positive 1. Excuse me. Fighting off a sneeze there. So now, of course, 2x and negative 5x is negative 3x plus 1. That's the big thing. That's one of those problems that's missed a lot because of that. That minus sign by itself, people tend to blow it off. And I mean, some of you in high school may have been taught to distribute the negative, which is kind of accurate, but really, there's a lot of places in math where there actually is a 1 and we just don't write it. For example, this is really 2x to the first power. We just don't write the 1 in there. Yeah, or if we just have x, it's really 1x, we just don't write the 1 in front of it. So here then we're going to subtract 1. Negative 3x equals 15, and then negative 3. X equals negative 5. Well, I'm sure you guys all had that, right? Cool. What happens when I do this? You cry, you throw stuff. I walk out the door into the parking lot, you hear revving engines. Something like this. Believe it or not, this is no different than stuff we've already done.
What is that symbol by the 5?
That's just a 1/4. Yeah, my handwriting sucks.
It's fine. I
There.
don't know what that.
You ever know when they're going to throw something funny in there? Where'd that come from?
How many symbols do we pull from different languages already that I don't know?
I think that is
I did.
simple.
No, it's not.
Perpendicular.
Oh, like this? Yeah, that's perpendicular, yeah. But now with a 4 under it. Yeah, there's some, we pull a lot of Greek symbols. Oh, yeah. Yep. Yeah, statistics, it's all about Greek. You know, mu and sigma and, yep. This one really is going to be just like having 5x minus 2 equals 38. What would be the first thing we would do to solve this equation right here? We would add 2, right? Over here, the first thing we're going to do is add 5 1/4. So we're left with 3/8 x. And over here, we've got 6 3/7 plus 5 1/4, which is 11 19/28. I'll let you guys verify that. You guys got the fraction calculators that'll do that if you need it to, or you can do it out by hand if you want to. 5 1/4. 11.67. Yeah, otherwise known as 11 19/28. There we go. So now what are we going to do? Divide by 3/8. So now, of course, 11 19/28 divided by 3/8. 11 times 28 is 308 plus 19 is 327 over 28. Yeah, I think it's times 8 over 3. So you can cross cancel the 8 and 28 divided by 4 to give you 2 and 7. 3 and 327 divided by 3 to give you 109. So 218 over 7, otherwise known as 31 1/7. Or if you're dividing it out on your calculator, 31.142857143 approximately. 31 1/7. Okay. And it gives you only the improper fraction if you're in math mode. So you have to hit the reduce button, the SD key. What do you guys think? That's not terrible, right? Doable. So how about something like that? I'm going to give you a second. Try that one in your notes. So for this one, first step, got to get rid of one of the x's. So get rid of the smaller one, 2.8. So this is now 1.4x minus 3.1 equals 5.3. And then add 3.1. 1.4x equals 8.4. Divided by 1.4. X equals 6. Good stuff? Good. We'll get there soon enough. What about something like this? We have two options here. One option I'm going to show you works well in certain situations, and the other option I'm going to show you works well in others. This one, this equation here in particular, works pretty well with either method, depending on what you prefer. Yeah, that's one way of doing it. The first way I'm going to show you is just this. X over 3 can be thought of as just 1/3 x. Because 1/3 times x is going to be x over 3. X over 2 then, of course, can be thought of as 1/2 times x. So now this kind of takes on the same appearance as if we had 5x plus 2x equals 35. What'd you do with the 5x and the 2x? Combine and make 7x. What are we going to do with 1/3 x and 1/2 x? Combine them. 1/3 plus 1/2 is 5/6 x. Right? May take you a little bit more work to get that than me, but that's where you're going to end up, 5/6 x. Now we have to divide by 5/6. x equals 15 divided by 5/6 is 18.
It seems like more work than just distributing. Reverse distributing or distributing?
It is just distributing. But it's a full distributing. You got to make sure you do the whole equation. The other method works like this. First thing we would have to figure out is what is the common denominator between 3 and 2? Least common denominator. Now, it doesn't have to be the least, but it's usually easiest if we have the least, which would be 6. We're going to multiply the whole equation, not just the left side, but the whole equation by 6. So now you have, we're going to do 6 over 1 times x over 3, which is 6x over 3, which reduces to 2x. 6 over 1 times x over 2, which is 6x over 2, which reduces to 3x, equals 6 times 15 is 90.
That's so shorthand, it's still not what I got taught to do. I got taught, because 3 goes into 15 easily, you multiply everything by 3.
Okay.
Come back and multiply everything by 2.
That's the same thing. You're multiplying by both of them at the same time. So now you've got the 3x and the 2x, make 5x equals 90, and you divide by the 5. X equals 18. One of the reasons why I don't do multiply by 1 and then the other is when you hit a problem like this. Oh, what do I want to do here? Something like that. X over 6 plus x over 8. I could multiply by 6 and then by 8, but I'm going to blow up the numbers bigger than I have to. That'd be multiplying by 48, basically. Really, I can get away, though, with just multiplying by 24. That's the least common denominator of the two of them. So, yeah, I mean, if you're struggling with least common denominators, multiplying by each of them separately is fine. So now we've got the 24 over 1 times x over 6 is 24x over 6. 24 divided by 6 is 4x. And 24 over 1 times x over 8 is 24x over 8, which divides out. 24 divided by 8 is 3x. 24 times 28 is, not everybody at once, 672. Correct? So then, 3x and 4x and 3x make 7x. 672 divided by 7. X equals 96. Good stuff. What's that? Yeah. How about something like this?
Just erase the left side.
Just erase the left side.
I think that one's it.
That she kind of does.
You just need to erase the 3, the plus the 7 behind the 4. I think you're good. Just need the X. Is that intentional? Is that like some math formula that does that every time?
Yeah,
And you use that to write your question because it's easier?
that's one of the ways. Yeah, there are a lot of little tricks to write questions that are easier. That's one of them. Like when we do Pythagorean theorem, there's a couple little tricks that you can make it so it always comes out to Pythagorean triple.
I say that looks. I've seen a lot of equations that just.
So on this one, if we're asking about how this was built, what was done to x to build it, it was multiplied by 3, 7 was added, and then the whole thing was divided by 4. So to solve it, remember, always take off the last piece first. So we're going to multiply by 4 to take that off. 7 times 4, of course, is 28. Over here, all that's left is the 3x plus 7. So, subtract 7. 3x equals 21, and divide by 3. X equals 7. So do you want me to show you the trick for that?
Yes.
Let's say I want x to be 9. So I'm going to throw out, got to make sure I make this work. That should work. Why does this work? I'm just going to, this is what I want x to be. This is what I want x to be. This, I'm just going to pick a number. Whatever I put there, this has to be one more.
Okay.
So I'm going to multiply by 6. 5x plus 9 equals 54. Subtract 9. 5x equals 45. Divide by 5. X equals 9.
See, if I'd have known this years ago, I could have done half my math.
Yeah. So pick a number that you want x to be.
12.
12. Now pick another number.
17.
17. So this will come out to be x equals 12.
Why did they not teach this?
I've told you guys before, math is all about patterns. And once you start to see patterns like this one, it's a definite pattern. Once you start to see patterns, the calculation is simple. The problems that I do in class, very seldom do I actually have example problems written in my notes. I'm usually making up those problems as we go.
Oh, I realize.
And you notice, and you see me pause every now and then, this especially when I'm tired, my mind loses track of it. It's because of these patterns that I can write those questions out, and I know exactly how they're going to come out. Yeah. But there's patterns, like this one. I mean, I can make up an infinite number of these that I wanted to, and I know what the answer is going to be, and I can make them up rather quickly. Like I said, once you, and of course, the only way to get good, I could try to teach you some patterns. You could memorize some of them, but unless you start to really see where they're coming from.
The plus always has to be for an
Yeah, this is going to be if x equals a, right? Oops. X equals a. This always has to be of the form of b times x plus a over b plus 1 equals a. And when you get good at math and you start looking at patterns, that's one of the things that's essential to start seeing patterns, is start to thinking rather in terms of numbers, but thinking in terms of generic placeholders, like variables basically. If you start seeing this, rather than seeing this as 17, 12, and 18, start seeing this as A, B, and B plus 1. Well, once you start seeing it that way, then you can fill in any numbers you want to and just very quickly.
This is why my math teacher used to get a problem every day. The whole class had to solve just achieving pattern.
Yeah.
I never understood why. This makes complete sense to me.
Yeah, because once you start seeing, like I said, Pythagorean triples. If I wanted to make a triangle that I know is going to work out, pick any number you want for this side. 72. Okay. 72 squared is 5184. Perfect. 5184. Now 72 is an even number, so I'm going to divide that by 4. $12.96, is that right? So that side will be $12.97. This side will be $12.95. That'll work out to be a squared plus b squared equals c squared will work out. Yeah. Squaring 72 is a pattern in itself. What's 7 squared? 49. That's 4,900. Anything with a 2 on it, what you would do, 71 times 4 is 284, right? If I want to square 52, you notice these are all ending in 2. It's if they end in 2 is where this pattern applies. What's 5 squared? 25. That's 2,500. So then 51 times 4 is 204. 52 squared, 2,704.
Squares and such big numbers so easily.
Yeah.
I've been trying to figure out how to do that for a while because I get like some of this stuff where there's patterns. That
Sure.
one has been brutal.
35 squared. Square anything that ends in a 2-digit number that ends in a 5 is extremely simple. That's a 3, right? What's 3 times 4? 12. 5 squared is 25. It's 1225.
Why is it 4?
Because it's one more. It's always one more than the 3. Like I said, if I want to square 85, 8 times 9 is 72. That's 7,200 plus 25. 7,225.
4 wasn't just an arbitrary number.
No, it's just one more than the 3. Like I said, it's all about, once you start seeing the patterns, the calculations are extremely simple. There are very few calculations out there that do not have a pattern to fit it. And even if you don't know the pattern, you're familiar with patterns, a lot of times you start doing the calculation, you get 2 or 3 digits into it, and you see the pattern. The pattern opens up, and you just go. For example, something like this. Walk me through, how would we solve that? So we're going to subtract 2.4x. Right? So we got 1.4x minus 5.1 equals 2.1. So I'm going to add 5.1. So I've got 1.4x equals 7.2. And then divide by 1.4. Well, that's not necessarily necessary here. But what you end up getting, first of all, 1.4 and 7.2 all have one decimal place, so I'm dealing with 14 and 72, right? Both of those are even, so I'm dealing with 7 and 36. Just like reducing a fraction, you divide them both by 2. Well, dividing by 7 has a definite pattern. If I can get it to a 7, it has a definite pattern. 36 divided by 7 is going to be 5.142857143 approximately.
I'm not going to remember that, but that makes sense.
Yeah. It is about time for our break. So let's take our break. We'll come back and we'll start up again at about 8:29.